We are now recording. Let me get just the last couple of announcements made. I think you've heard most of these before. Math team's still looking for a few good people, okay? They got a really good crowd, but, you know, the more the merrier. One of my students in my Monday, Wednesday morning class has been going to it. He says they're having a lot of fun, and he's learning loads of math. I can tell the difference of him in the class because he sure seems to have great understanding, and he was a little uncertain earlier. So if you can go, it's Fridays, 12 o'clock noon, Birmingham West Campus, the Science Building, which is the C Hall, C100, the door closest to the library in the C Hall, on the outside part of the building. And then again on Monday afternoon at 3 o'clock, they meet again, same place. Mr. Rossi is the coach for that. Tutoring, we have tutoring down the hall here at Student Support Services. Great tutoring there. That's in room 202. Or go downstairs to room 105, and they have the Space Center tutoring. Both of these have plenty of tutors available, and they're looking for good tutors. If you've made, and I'm sure you have, an A or a B in an earlier math course, you qualify to tutor in those courses. So take advantage of it. Earn a little money at your schedule. They don't set the schedule for you, you do, and go from there. All right. One other announcement is it almost doesn't seem like it's true, this term anyway. I'm scheduled to have office hours on the Birmingham campus, 7:45 to 11:45 on Fridays. So far this term, I've had, I think, 4 or 5 treatments on Friday so far. I had a meeting on Friday, and it seems like something else. So I haven't been on Birmingham campus frequently this spring. Early on I was, but not recently. But I won't be there again this Friday, tomorrow, because I've got my annual physical. Yes? How are your treatments going? I'm sorry? How are your treatments going? They're going great. They make me very fatigued. Not as bad as that first round did, but still I'm tired. And like I say, it sometimes messes with other things like joints are a little stiffer, and that kind of stuff. But the bad counts are falling like crazy. In fact, they fell after the first week. Actually, it's the good counts are now coming back up. The treatment also has some collateral damage to red blood cells and platelets and things like that. So those are improving, but the red blood cell being low, that's what makes me so fatigued so easily. Okay. Don't know what it is that's making the joints ache, but it's livable. Okay. But thanks for asking. All right. So anyway, after tomorrow, then I think I'll be on Birmingham campus. I think I just have 1 or 2 more treatments this term, and we're down to once a month now rather than once a week. Once every other week, we're down to once a month. So I'll only be going 1 out of 4. Tomorrow is the physical, so that's another issue. All right, any questions on anything we've covered so far? All right, by my mark, we're at the top of page 118. It's example 3. They don't have example 3 or 4 in the slide set, so that's what we'll be doing now. Okay? I can't get my color to come. There it goes. All right. Find the vertex and x-intercepts of a parabola. It says sketch the graph of f of x is equal to, and here's Gavin. All right. Sketch the graph of f of x is equal to negative x squared plus 6x minus 8. And it says identify the vertex and the x-intercepts. Okay? Vertex, of course, is going to be an ordered pair. and x-intercepts are probably going to be 2 ordered pairs. The odds are that's the case. May have none, may only have 1, but usually we'll have 2. Okay? Where would you begin? Help me. Second? You certainly could factor. What will factoring give you? It answers 2 of the questions. What's that? Plug in.
Plug -2 in the x.
Okay. Wait, now that -2 at the top is the previous problem. That's example 2. Yeah, this is example 3. So the line's that. Now, factoring will give you your x-intercepts. Okay? And so that's not a bad thing to do. So you want to go on and factor it? You said it first. You don't have to do it now, but you can. You want to factor?
So it's the easier way. It's an easier way.
Well, no, I mean, you've got to do that at some point to get the x-intercepts. That's how you get x-intercepts. Of course, you do one thing first. Okay? You don't just factor a function generally. That's not usually all that helpful. But what you do, what is true about the x-intercepts? Seems like I asked this. Say again? What's true about it? A lot? Okay. Okay, yeah. Okay, the main's all real numbers, yeah. What's true about an x-intercept? Where do you find your x-intercepts? What do they call them? X-intercepts. Say again? Yes, those are the points where the graph crosses the x-axis. Now, what's true about every point on the x-axis? There's the x-axis right here in front of you here. What's true about every point on this x-axis? In ordered pairs. Okay? What's 0? The y is 0 because you're neither up here where it's positive or down here where it's negative. The y is always 0 on an x-intercept, right? Now, where is y in this problem? Say again?
-8.
No, where is y? This is the question I've been asking from the very beginning. Most important question to answer in this course. What is your y? F of x. That's your 0. That's your y. You set that equal to 0. Then you factor. So set this equal to 0, and then you do minus x squared plus 6x minus 8. Now, generally, I don't like leading off with a negative. But that's your function. But we're not interested in the function right now. We're interested in that equation right now. So with equations, there's a lot of things you can do. For instance, multiply both sides of the equation by the same number. Or divide. Just don't multiply or divide by 0, okay? That wipes out all meaning. But what could you multiply or divide by to get rid of that minus sign? A minus sign, okay? So we can rewrite this, because -0 is still 0, is equal to x squared. Help me. Minus 6x plus 8. Very good. Now that I find it just is easier to look at and factor.
So you divided -x by the whole problem.
Okay, you either multiply or divide both sides of the equation, everything on both sides by -1.
Okay.
So -1 times 0, or 0 divided by -1, either one gives you 0. -1 times -x squared is positive x squared. -1 times 6x is minus 6x. -1 times -8 is positive x. Or dividing these by -1. It does the same thing. Okay? Now, this is all to get your x-intercepts. That's all it's doing. It's not doing anything else but getting x-intercepts, because we set y equal to 0 for this function. Okay? Now, let's see if we can factor it. Don't know that we can, but let's try. What would you do first? X times x. That's going to give you x squared. Then where do you look next? The sign of the last term, which is positive. That tells you what about these two signs? They've got to be the same. And since the middle sign is negative, they both got to be negative. Now you want two numbers that multiply to be 8, add to be 6. 2 and 4. Got it. Okay? And by the way, x-intercepts, as soon as I wrote down those ordered pairs there, what can I write in?
0.
For where? Y. 0 there and 0 there. So all I got to fill in is the x values. And where they're coming up right now, what does this tell us? X minus 2 is equal to 0, or x minus 4 is equal to 0, and some of you jump right to the chase and added 2 to both sides, or just solve, it's going to have to be 2. X equal 2, or adding 4 to both sides, x equal 4. For some reason, pen's not always writing. So now we can plug those in. 2, 0, 4, 0. Answer 2 of the 3 questions. However, that doesn't tell you much about the vertex. Except, now this is doing it a slightly different way, and since you started it this way, it's all, his fault, Kendrick's fault, But if the one x-intercept is here and one's there, where's the vertex got to be? Melva brought it in, right? Oh, yes, okay. We've been waiting for the vertex till you got here. Okay. All right. Is anyone else come in since I called roll? Okay, now this is not the normal way to do the problem. Since you started it this way, you certainly can. What's true about a parabola? It's symmetric about the axis of symmetry, line of symmetry, right? And symmetric means whatever's on one side of it is going to be equal distance on the other side. And since you got x equal 2 here, x equal 4 there, on the same line, the x-axis, guess where the... Yeah, it's got to be at 3. So we know the vertex, the x value, has got to be at 3. Look at that. Now this is not the normal way you do this, but it certainly works. Okay? And if x is equal to 3, how do we find y?
-8. Oh, no, 8.
Okay. You keep going for that -8. -8 is your y-intercept. That's where x is equal to 0. They didn't ask for it, but since you came up with it, we'll do it. The y-intercept is x is 0 and y is -8. Okay? So we got another point. Okay? Now, actually we have 2 more points if you really wanted to, because 0 is 3 to the left of your axis of symmetry, x equals 3, you can go to 3 to the right. And what would that value be? 3 to the right of 3 would be 6. And what would the y value be? Now, -8, because it's symmetric. So there's another point that we didn't even look for. 6, -8 is another point on that graph. Okay? Okay? Did you agree that 0, -8 is your y-intercept? Yeah, you just put x equals 0, y is equal to -8. Yeah. Okay. Now, we've already determined your axis of symmetry's got to be 3 because it's halfway between 2 and 4, right? And Chris decided to show it. Okay, good deal. Okay. Anyone else come in since the call roll? I'm sorry? If you want. Can you do it during office hours? Okay, yeah, let's do it because this is new material. Okay. All right. So we already determined that x equals 3 is your axis of symmetry, right? Okay. And we also just determined that 0, -8 Let's do it right here. 0, negative 8. Okay, x equals 3 is your axis of symmetry. Get mine. I don't use chalk much, but I always bring it in case I need it. Ooh, that might do it. Old stuff. Okay. We had 2 zeros and 4 zeros. Those were our x-intercepts. Kendrick had us calculate those first. That means that the vertex has to be on this line right here. X equals 3. Because parabola are symmetric. Huh? Oh, okay. Kelsey, got it. All right. All right. So we know that's your axis of symmetry. The vertex is somewhere on that line. And then Kendrick kept trying to get us to use that negative 8. Well, the negative 8 is the y-intercept, where x is 0. So 0, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. It's right there. Well, guess what? Because of the axis of symmetry, this is 3 to the left of 3, so 3 to the right of 3 will be another point. And that is 6, negative 8. See where that came from? Okay, pictures are worth more than words, okay? A lot more, okay? So that gives you that. Okay. Now, my original question is, if we know the vertex is the x equals 3, what's going to be the y-coordinate for that? This is not the normal way to do it, but it certainly works. Okay? If x is 3, what is your y? Second? How can you do that? Okay? If it's 3, 0, that means this is a flat line right here, you know. That's not going to be a parabola.
Oh,
yeah, you plug it in. If you know that x is equal to 3, plug in here and get what the y is. Alpha 3. That's your y at 3. Right? That's what plugging in does for you. So we plug in the original one. That's the function. That tells you the ordered pairs. Okay? So alpha of 3 is equal to minus what? 3 squared plus 6 times 3 minus 8. Okay? Let's plug and chug. What is minus 3 squared? Please excuse, do your exponent first, then you do Aunt Sally, which is minus 9. Right? Right? Plus 18 minus 8. 1. So your vertex is 3, 1. Okay? Now, y'all chose to go this route, but it certainly works. So now we know another point. You could come really close to graphing this thing right now. And did they ask you to? Yeah, sketch the graph of this. Okay? Now, I don't have a lot of room left, so what I'm going to do is write these points up here. The vertex is 3, 1. Okay? The x-intercept, 2 of them, are 2, 0 and 4, 0. The y-intercept, Kedrick was just so anxious to do, that is 0, negative 8. And then from that, using our axis of symmetry, we found another point being 6, negative 8. That was a freebie. Took almost no effort to get. And then there, that's all we got, right? All right. So I'm going to erase most of this. Okay? And we're going to go back and I'm going to show you the way the book probably does it. I have a look to make sure, but this is the way they typically do. Because they ask for the vertex first, that's what they're probably going to go for first. You know, I could have just left those there. Should have, probably. But since I've written them above, yeah, I'll go and erase them. Got them all right, right? Yeah, okay. Okay, because we are going to graph and we need to space the graph. In fact, you want to go on and graph first? Or, well, let's do the way the book suggests. Okay. Here's how they were probably recommending that you do the problem. Okay? To find the vertex, it's usually a good idea to get the function in standard form. Remember we did this maybe Tuesday? I know it's 2 long days ago, so a lot of opportunity to forget it. But how did we go about doing what does standard form look like anyway? Anyone remember that? F of x equal. Anyone remember? Say again? Say again? You're going to have that in there somewhere. It starts with an A times x minus h squared plus k. That's your standard form. Okay? Now, is that at all related to this? One thing is. What's that? Your A is the same here as it is there. What's your A here? -1. Right? So the first thing we're going to do is factor out the -1 because that's factored out there. And we're only going to do that for the first 2 terms. So that's going to be a -1. I'm going to write it. Normally I don't. Times x squared. Factoring out a -1, what does that give me? Second? No, it's a minus here, isn't it? The x squared is plus, but the next term. Minus 6x blank, remember that obnoxious blank, minus 8. Okay? Now that hasn't changed, has it? This is the same as that. It's just you multiply through here, changes these 2 terms, leaves that one alone, right? Why I did this is so you can, what's that practice called? The technique called? Okay, completing the square. And what you do is divide that middle term by 2. So that gives you a -3. And then what do you do with it? Square. Okay? Now you do something else with it too. I'm going to show you this one. So let's write down, our next line is going to look very much like this. The A is going to be a -1. And we're going to put our X. And when you said half of -6 is -3, it was a X minus. When it's a -3, that makes a +3 squared. As soon as you take half of that middle term, you know what that number is going to be there. Okay, but what you do with half of that, -3, square it, and that gives you +9, right? Okay, now what you just done is change this problem, haven't you? And how do we change it? -9. So to get it back to what it was before, we have to add 9 over here. So sure enough, there goes a +9. Okay. Okay, wait just a minute. Let me get Jayla here before I forget to. Okay, now what's your question? Oh, no, go ahead. Oh, okay, well, I'll try that technique again. Okay. Just put you off a little while to figure it out. Okay? Now, so the -1 is the same here. This is the perfect square of that. That's the perfect square of this, right? And what does this come up to? Plus 1. Okay? Now, my question to you is, what were these H and K's anyway? Say again? Yes, that's the X and the Y coordinate of your vertex. Your X is the opposite of this, -3. Whoa!
That's supposed to be a minus.
Yeah. Yeah. Oh, yeah. Wait. Yeah, you're absolutely right. That's a -3. How in the world did I do that? I don't know. All right, now we got it. Okay, was that what you were going to ask before? You got it right. Okay, I blew it. Okay, because I have the minus sign up front. Okay, so that makes the vertex 3, 1. So that's how they went about getting the vertex, getting it in standard form and doing that. How we did it, because Kendrick was insistent that we find those x-intercepts first, we did that. And as soon as we saw that, we saw, well, the line of symmetry has to be x equal 3, so plug x equal 3 in here, and we got the same thing. We got y is equal to 1. So there's several ways to skin cats if you don't like cats, you know. So, no, you don't have to go there. Okay, so that gave you your vertex, and then just like we did before, set this equal to 0 and get your y-intercept, x-intercept. Why is that true? Because that is, when it crosses the x-axis, the y is always 0. So that equals 0, factor whatever you need to do that. The x-intercept we just got for free, almost, because you just say x equals 0, that gives you the y-intercept. And then since you have that and you know the line of symmetry, and what is the line of symmetry, by the way? X equal 3. Exactly. Always write it that way. They didn't ask for it, but the line or the axis of symmetry is x equal 3. Whatever that, that's not what I wanted to do. Axis of symmetry. Yuck, that's not what I want to do either. Okay, let me get this back where I want. Axis of symmetry is x equal 3. X equal 8. Whatever your h is, x equal that, that's your axis of symmetry. All right, now we can graph the function, because that's what they asked for. Can I go on and erase what I just did, because it's taking up room down here? But you see, you got the 3, 1 from that too, okay? So let me go on and erase this. That just was confirming what we already had. Okay. I'll even erase this because we know it now, don't we? Yes. Okay. Okay. Let's draw our coordinates here. And if you notice your points here, it looks like not very many high y values. In fact, the vertex is a 1. All the rest of them are zeros and negatives. So let's just put the x-axis somewhere about here. And we'll do 1, 2, 3, 4, 5, 6, 7, 8. And Tadarius is here. If I can find it. There you are. Anyone else come in such a called roll? You didn't hear me acknowledge you. Okay? And we'll do negative 1, 2, 3, 4, 5, 6, 7. Okay? Something out there. We're not going to need it. And we need to go up at least 1, 2, blah, blah, blah. And then we'll go down 1, 2, 3, 4, 5, 6, 7, 8. I want to get down to 8. So I made them switch in there a little bit. So let's plot our points. Where's 3, 1? Where is 3, 1? Say that again. Okay, when you say over, what do you mean? right 3 and up 1. Okay, just don't say yours. Okay, good. And then the next 2. 2, 0. Where's that? Right 2 and don't go up or down. Next. Right 4, don't go up or down. Okay, on the x-axis, those are x-intercepts. Very good. Okay, 0 on x and go down 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's your y-intercept. Now, while I'm here, I'm going to go on and draw my axis of symmetry. Okay, and that's at x equals 3. Okay, so I'm going to plot that in here. Okay, that makes it a little easier to do what I'm going to do next. Is the next point. Well, my pen didn't come back. Nope, I need my color to come back. There we go. Is 6, negative 8. So that's right 6. That's 3, 4, 5, 6, and down 8, 2. There it is. Okay, somewhere. Don't think I went over far enough. Somewhere like there. Okay. I don't draw too well, as you have already noted. Now, since we're here, now I wish I had left that other function up there. Yeah, why didn't I think of that? I'll go and write it again. Okay? Then standard form we had f of x equal negative 1 times x minus 3 squared plus 1, right? Yeah, okay. Now, it looks like we could plug in 2 more points pretty easily. Okay? We got this one and that one, this one and that one and that one. So 1 and 5 we're missing. Which one would you rather plug in? 1, I like that too. So I want to plug, actually, in this one, 1 isn't hard to do here either. Here's a little trick. When you're plugging in x equals 1, just add your coefficients. Because 1 squared is 1, 1 is 1, so just add the coefficients. Minus 1 plus 6 minus 8. Negative 3, 2. These 2 is 2. Negative 3. All right, negative 3. So 1, negative 3. I didn't need that form, okay? 1, negative 3. And then what can I do over here? 5, negative 3, okay? Now we got our parabola sort of shaping up here. Here we go. Ooh, I can't get it to right. Okay, I'll start here and go down like this and down like that. Something like that. I don't draw too well. I didn't catch my negative, my 4 very well. Okay. There's the parabola. There's the sketch. Helpful to have the x-intercept. Helpful to have the vertex. Helpful to have the y-intercept and its corresponding point. And then we plugged in one more with its corresponding point. There we got it done. Right? Okay. Let me, since I wrote it up here, let me do. What if Taylor would have said, go for 5, not for 1, for that other point? I don't want to put 5 in here because that's really hard to do. I mean, big numbers. I could do it. It's not that bad. But if you do 5 here, it's a lot easier. 5 minus 3 is 2 squared is 4 times the minus 1 is negative 4 plus 1 is negative 3. There it is. 5 negative 3. So that's not hard either. Okay? And then we knew its corresponding point would be 1 negative 3. See? Axis of symmetry. Make sense? So you can approach these several ways. Do what makes sense to you. Got it? So that's example 3. Wow. Took a while, didn't it? Okay.
So on our test, what would we have to show?
Say this again.
On our test,
What about it?
what would we have to show? Like, what would you ask?
I would probably ask something just like this, saying, sketch this graph, identify the x-intercepts, the vertex, I may even throw in the y-intercept, and line axis of symmetry. We did every one of those here. Right? So, go for it. Several ways to get there. How you get there? As long as they're legal steps, you can do it. Since you started with the y-x-intercepts first, that just told you, goodness gracious, that vertex got to be somewhere at x equals 3. So that's got to be your axis of symmetry. We didn't know if it's up there or down here, except that we had a minus here, so we know it has to be, the vertex has to be up there. And then, cleverly noting the y-intercept that was here, we got this other point, since that's your axis of symmetry, and then just plug in another. We did that without ever really getting to standard form. The standard form gave us our vertex really easily, so that was useful there. But we didn't have to use that, because once we knew x equals 3 for your vertex, you can plug that in here and get what the y value is. And that's what we did. And it was pretty easy. So there's lots of ways to get there. I don't care how you get there. I want right answers. As long as you give me right answers, I'm a happy camper. Okay? So do it however you prefer to get there. The book likes this method, and it's fine. Perfectly fine. Okay? So let's do example 4. Can I erase this now? Okay. Example 4. This time we're going the other way. Before they gave us a quadratic equation, a quadratic function, and said, now, graph it, find the vertex, find the intercepts, all that kind of stuff. This time they're going the other way. They say, write the standard form of a quadratic function whose graph is a parabola, so that means it's going to be a quadratic function. Okay, that was redundant, wasn't it? Any graph of a quadratic function is going to be a parabola. A parabola is going to produce a quadratic function. So that was redundant to say that. With a vertex of 1, 2, and it passes through another point, 3, negative 6. Okay? It says write the standard form for the quadratic function whose graph is a parabola with a vertex of 1, 2, and passes through that point 3, negative 6. First question to you is, how does the standard form look? F of x, good start, is equal to a times x minus h, second? Okay, squared plus k. Don't forget the square. It's a quadratic, it's got to have the x squared. That's it, folks. Now, based on what they gave us, what can we plug in right now? The h and k, because that's your vertex. So tell me what this function is going to look like now. F of x is equal to a times, say again, x minus 1 squared. Don't forget the square. Say again. Plus 2. Got it. You're 2/3 of the way to having this answer just by plugging in the vertex. Boy, this isn't hard, is it? Okay? Now, what we have to do is get A. That's all we need is to get A. How are we going to get A? What haven't we used yet? That point right there. What does that point tell you? When x is equal to 3, y is equal to negative 6. And where's your y here? I don't see a y. F of x. Got it. Okay, so let's plug that in. Instead of f of x, we put the y value, negative 6, is equal to a. We don't know that. That's what we're looking for. Times, and what's your x? 3 minus 1 squared plus 2. Okay? That's an equation with one unknown, a. All you have to do is solve it. So let's solve it. Minus 6 is equal to a. What's 3 minus 1? 2 times 2 squared plus 2. So minus 6 is equal to, what's 2 squared?
4.
So that'd be 4a plus 2. I think I can probably even do that one. How do you proceed? I like that. We're trying to get A, so let's get everything away from the A. Minus 2 from both sides, and that gives us negative 8 is equal to 4A. Divide both sides by what? 4. And that gives us A is equal to negative 2. Now we just fill that in. F of x is equal to negative 2 times x minus 1 squared plus 2. There it is. Done. Okay? And if you wanted to, you could plug in and see if it works. It should. You plug in a 1 for x, you get a 0 here, you get a 2 for y. Hey, that works. Plug in a 3 for x. 3 minus 1 is 2. Squared is 4 times negative 2 is negative 8. Plus 2 is negative 6. Yes. Both of those points are on that curve. I feel really warm and fuzzy about it. Okay? Make sense? All right. Now, by the way, I haven't been saying this lately, but let me say it again. Every one of these examples has a checkpoint. And so I would say as soon as you're out of class and have a little free time, try to do these checkpoints. And if you get stumped on them, guess what? Go to LarsonPrecalculus.com and they have the checkpoints done for you. Audio, video solutions. Okay. So let's now move to finding the minimum and maximum values. Okay? Now, I sort of apologize for this, but it doesn't really hurt that badly. I just showed you how to get the vertex by going to standard form. Now they're going to show you another way, which is really pretty easy. Remember when we were finding the solutions for a quadratic equation? If you couldn't factor, the next thing we did was completing the square. And everybody loved that so much, didn't they? Not really, okay? But then we used completing the square on the whole function and came up with the quadratic formula. All you have to do is plug in A, B, and C, right? And that was a much easier way to do it. But it came from completing the square. Well, guess what? We're going to do sort of the same thing here. Finding minimum and maximum values. If it's a quadratic function, what's going to be your minimum or maximum value? The what? 4. 0. No. Okay, yeah, okay. All right, technically, one of them is going to be an infinity. That's not what we're looking for. In a parabola like this, what's the minimum value? And what do we call that? The vertex. And if it's going like this, what's going to be the maximum value? The vertex, okay? So if we know the vertex, we know the minimum and maximum values, one or the other. And the other is going to be infinity because it goes forever, okay? Technically, okay. So many applications involve finding a maximum or minimum value of a quadratic function. By completing the square, oh, our favorite, right, of the quadratic function, f of x equal ax squared plus bx plus c, you can rewrite the function in standard form. But this time we're not going to have numbers there, we're going to have the letters. Just like we did for quadratic equation. Okay? So let's do that. Okay? So what we have is f of x is equal to a x squared plus bx plus c. Okay, now what was the first thing we did? Divide out the a, right? Out of the first two terms. That's a times, and that leaves in the first term x squared, right? But then what we had to do was divide b by a, right? Because you're dividing out a. So it's going to be plus b over a x, right? Blank plus c, right? Now that's the same thing as this, isn't it? If you multiply through, distribute through, a times x squared is ax squared, right? And a times b over a is bx, right? and then you got your plus c. So we haven't changed anything except made it look worse, okay? But then what did we do? To complete the square, take half of that middle term, the linear term. So half of b over a is b over 2a, right? Half of that divided by 2, b over 2a. So we did that. So b over 2a. And remember I said you can come down now and write it down here, x plus b over 2a squared. That's what it's going to wind up being. But then what did we do with it? You squared it. So b over 2a squared would be a plus b squared over 4a squared. Right? But now what have you just done? Okay? You made a mess, didn't you? Okay? What you just did was add to this thing a times this, which is b squared over 4a, because 1a cancels one of those. So since you added b squared over 4a, we've got to subtract with that. This is doing with letters what we did with numbers before. Minus b squared over 4a. Okay? And guess what? This part right here is that, and this is plus c minus b squared over 4a. The 4? Okay? Remember what we did here? Took half of this, that's b over 2a, and squared it. Because you took half of b over a. Okay? Multiplication of fractions. 1/2 of b over a. That's b over 2a, isn't it? Right? You just took half of b over a, and that's b over 2a. Okay? And look at what we got. A times x plus b over 2a squared plus c minus b squared over 4a. Guess what? We never use this. Don't even worry with it. This thing right here. That one. What we do use is this. That gives you your h. Minus b over 2a. That was your h, right? The opposite sign of this times this. B over 2a. That's your h. Right there forevermore. So you don't have to go back and complete the square again. If you want to know what the x-coordinate of your vertex is, just do b over 2a. Minus b over 2a. Right? That's what it is. Minus b over 2a. So looking at this thing right here, you don't have to get it in standard form. Just do minus b over 2a. Now, does that sound a little familiar? Let's go back to the quadratic formula. How does that go? In that case, it's ax squared plus bx plus c. I'm sorry. I'm getting ahead of myself. Plus c is equal to 0. We're trying to find solutions for that, right? And what was the quadratic formula? X equal minus b plus or minus, no one remembers this, do you? Square root of b squared minus 4ac all divided by 2a, right? Now look at this. Look at this. Your part of this is minus b over 2a, the vertex, the h of the plus or minus other stuff, which if you fiddled with this, it comes up being close to this. But that's what your vertex is here, and then the other stuff is there. Plus here, minus this. So who cares about this? Minus b over 2a, that's what your h is. Okay? So, all that stuff we did about completing the square, that was fun, wasn't it? And you got the hk just like you needed. This way, all you do is get the h is minus b over 2a. Now, how can you get your k then? If you don't want to do all that mess, just plug it in. Once you get h minus b over 2a, then plug that in for x, and you get your y. And that's your k. Right? Because they come in hk pairs. So that's how they got what they did there. So the vertex of a graph of f is always, the x-coordinate is minus b over 2a, and then the y-coordinate is plugging that into your function and figuring out what the k is. So the minimum and maximum values of the quadratic functions, consider the function f of x equal ax squared plus bx plus c. That's how most of them are going to be written, right? That's how we write them, okay? They're not standard form, but it's the usual way we write them. So if you got this and you want to know what the vertex is, minus b over 2a. Done. That gives you the vertex. Then if you want to know, the h, that gives you the h. To get the k, just plug in minus b over 2k here, 2a here, minus b over 2a here, and solve. Just evaluate this at x equals h. Okay, now, how do you know if the parabola is opening up or down? Yes, what the sign of A is. If A is positive, it's a minimum because it's opening up. So that value is at x equals minus b over 2a, and the minimum value is the k, L, at minus b over 2a. And if that a is negative, then that's going to be a maximum value because it's opening down. So that's going to be a maximum out there at the vertex at x equals minus b over 2a, and the maximum value would then be f of that, your k value. Just plugging it in. Okay, that was pretty straightforward, isn't it? It took a little bit of wangling to get there, but once you get there, it's pretty easy. Okay? Here's example 5. The path of a baseball after being hit is given by the function f of x is equal to negative 0.30032x squared plus x plus 3. Wow, what a good formula, okay? Where f of x is the height of the baseball in feet, so that's the y value, and x is the horizontal distance from home plate in feet, okay? And then it says what is the maximum height of the baseball. So if you're in the Super Bowl, are you going to hit the ceiling? You know, probably not, okay, but we'll see, okay. Now, this, you don't need to know this, but in case you're interested, okay? Where did that come from? Notice we're using feet, so we're in the U.S. customary system, and that has to do with the acceleration. And the acceleration due to gravity in the U.S. customary system is 32 feet per second squared. Okay? Now, that doesn't explain where all the decimals come from, but that's where the 32 comes from. Okay? Now, the x, okay? Let's forget about x for right now. And it has to do with the speed at which you hit the baseball. And they're not given that in the problem, but that's where it comes from. You assume that's about 100 feet per second is what you're going to hit. And that's, when you square that, you get 10,000. And when you make that, move the decimal 3 places, make that 4 places, make it a 1, that's what moves the 4 places of the 32 to make it that. So don't worry about that, okay? Then the last one, the 3. When x is equal to 0, your height of the baseball, F, is 3 feet. When x equals 0, you're at home plate, and that's where you're swinging. And if you go and hit a good ball, where do you usually want it to be? Right about waist level, which is right about 3 feet, right? I'm 6 feet tall, but 3 feet here, 3 feet here, yeah. Right, that is your height of the baseball when you hit it. So yeah, this formula kind of makes sense. Okay? All right. So how are we going to figure this out? Where X is horizontal distance from home plate to feet, what is the maximum height of the baseball? Where is that going to happen? Well, first, what kind of function is this? Maximum exponent of 2. What kind of function do we call that? A quadratic function. And what does the graph of a quadratic function always look like? A parabola. And is this opening up or down? Opening down. So that means the highest point is going to be your vertex. So if you want to know what that maximum height is, you want to know what K is, right? Now you could try to do this by standard, get it in standard form. Please don't. That's messy. Really messy. But finding H is pretty easy, isn't it? Not going to find K, but finding H is pretty easy. What is your H? From the previous thing? H is equal to? Oh, it was a long time ago. No! What's your H? Negative B over 2A. I went through all that thing. That's going to be minus B over 2A. That's all you need to know. Well, what's your B here? B is 1. And what's your A? Ooh, yeah, it's that thing. There's your A. So this is going to be a minus 1 over 2 times a negative 0.0032. Okay, that's not pretty, but it's not hard either. So what is this? Well, I see a minus in the denominator and minus out front. So what I'm going to do is go on and get rid of those and make it plus. That's going to be 1 over 0.0064. So if you, yeah, right, I made it positive up front, okay? And then pull out your handy dandy calculator and do 1 divided by 0.0064. Your calculator's talking back, huh? Say again? 166? 56. Okay, I'm sorry. I don't hear well. 56.25. Whoa, come on back. Okay. And that's going to be in feet. That's how far from home plate you are when it reaches that maximum height. So what do we do now? Plug that in your function. We want to know what the height, F, is going to be at 156.25 feet. And that's going to be negative 0.0032 times 156.25 squared plus 156.25 plus 3. Don't forget your plus 3. Okay? Now, I'm not about to do that in my head. Okay? So pull out your handy dandy calculator, plug it in, Negative 0.0032 times 156.25 squared plus 156.25 plus 3. What do you get? 89.125 again in feet. 81. Okay, I can't hear well. Okay. Okay. And guess what? That won't hit the roof of the Superdome. Okay. So don't have to worry about it. Okay. I don't think you can hit a ball hard enough to hit the roof. So let's see what they got. I just did notice this. I should have done it on example 4. I wasn't looking at the book's answer. The book wrote their answer wrong. back on the bottom of page 118, right above the checkpoint, it says the function in standard form is f of x equal -2, we got that, times x minus, your h was 1, not 2. So that should be x minus 1 squared plus 2. Your y was 2. So you might want to make a note, unless your new edition has that correct.
No.
Okay, yeah, you might want to make a note they got it wrong. So anyway, here we have the maximum height of that ball was 81.125 feet. And by the way, there's a checkpoint right there too. And then the summary. And then we didn't have time for vocabulary. So you want to start with vocabulary next time? Yes, you love it. I knew you did, okay? We'll start with that next time. Homework exercises. Do either 5 or 7 or both. In fact, I would do all 4 of those, 5 through 8. You'll only find the answers for 5 and 7, but they're really easy to do, so I would do all 4 of those. Then do sketch the graphs 9 or 11. Both of those are at calcchat.com. 9 is at calcview.com. Then do any of the odds 13 to 25. All of them are at calcchat. Only 17's at calcview. Then do any of the odds 27 through 33. They're all at calcchat. None of them are at calcview. Do number 35. It's at calcchat. Do any of the odds 37 to 45. They're all at calcchat. 37's at calcview. Do either 47 or 49. They're both at calcchat. Do any of the odds 51 to 55. They're all at calcchat. Do any of the odds 57 to 61. They're all at calcchat, but 57's at calcview. Do either 63 or 65. They're both at calcchat. Do number 67. It's at calcchat. Then do any of the odds 69 through 73. They're all at calcchat. None of them are at calcview. You can look at 75 if you'd like. It's a true-false. And you can think about 77 and look at 79 and 81. 81's a proof. So we'll start next time with the vocabulary, but then we'll move in to 2.2. Yes, ma'am.
Are you teaching math 110 in the summer?
I usually don't. I can't guarantee I won't be, but most of the time I don't. No.
So when you
Usually
teach
Dr.
it
Dr. Thomas sometimes teaches it, and sometimes that does, if it makes. Yeah.
But if you teach it, it'll be during the regular semester, fall semester.
I don't usually teach 110. Usually they teach it, yeah. I usually do the calculus side of things. I have taught it before, but I just usually don't.
Miss Cummings and Mr. Holloway, I think they
Yeah, those are, yeah. Miss Lewis teaches it online, and then there's,
You should do it online.
I probably do it.
yeah.
Did
Yes,
you
ma'am.
did y'all do 2.1 today?
What's that?
Did y'all do
Yeah, we
2.1?
finished 2.1, and we didn't get to do vocabulary. We'll start there, all those exercises, and we'll start 2.2 after we do the unit.
Okay.
Good deal. Thanks for your patience.